this problem. A uniform rod PQ of length 1 meter and mass 2 kg is pivoted at the end P. If a load of 14 Newton is placed at the center of the rod, find the force that should be applied vertically upward at Q to maintain the rod in equilibrium horizontally. Now, you should know that this problem is from moments of a force. Now, we're going to draw an horizontal line to represent the rod. So, this is our rod, and a uniform rod PQ, it means that we're going to put this end to be P and this to be Q. Now, of length 1 meter, it means that the length of the rod is 1 meter. So, I can easily say that from here, I can do something like this to represent the distance. So, here, 1 meter, this is just to show the length of the rod. From here to here is 1 meter, right? Now, a uniform rod PQ of length 1 meter and mass 2 kg. Now, see this mass, we are going to change it to weight. This is the mass of the rod. Now, but we are going to change it to weight of the rod. And how do we change the mass to weight? That is by multiplying by G, which is acceleration due to gravity, by multiplying by 10. So we are going to say the weight of the rod, weight W is equals to mg, and that's going to be equals to 2 times 10, which is going to be 20 Newton. Now, remember, we just changed the weight or mass of the rod to weight. Now, what are we going to do with it? We are going to do something with it. Now, remember, the question says uniform. So anything that the question says is very, very important. So, because the question says uniform, it means that the weight of the rod that you have, it is acting at the center of the rod. So anytime the question gives us says uniform, it means that the weight of that object is going to be at the center. So the weight that we found here, we must put it at the center because the question says a uniform rod. So this has meaning, any question that you see. So this weight, put it at the center. Remember, the length of the rod is 1 meter. So I'm going to put it, let's say, assume that this is 0.5. So I'm going to put this to be what? To be 20 Newton, right? So this is the weight of the rod. And the distance, it means that the distance from any point here, that's 0.5 meter, right? So it means that this is the center. We have to put the weight at the center. Why are we doing that? Because the question says uniform rod. It means that the weight of that object, you always act at the center when the question says a uniform. Even if the question asks you to find the weight, you still use a variable to represent it, and then still put it at the center if the question says uniform. So we are done. We have made use of this. We have done the length PQ. The length is 1 meter. We have represented it. And mass 2 kg. We have done that. Change it to weight and then put it at the center. Now, it's pivoted at the end P. Remember, this rod PQ is pivoted at the end P. It means that we're going to put a pivot here like this. So that is what it means by it is pivoted at this end, right? So, okay, so that is good. And then once you have done that, then we can continue the question, right? If a load of 14 Newton is placed at the center of the rod, remember, we only have the weight of the object acting at the center, but the question is now telling us again that if a load of 14 Newton is placed at the center, imagine you are putting another load here at the center, and the weight of the load is 14 Newton. How are you going to put it here? Well, you can just do something like this. Since this is 20 Newton and you are stopping this, this from here to here, then you can say, okay, imagine that when you put this like this, then let's say this is 14 Newton, right? That is 14 Newton. Remember, you know that force, weight, they are vector quantities, right? So it means that they have magnitude and direction. So meaning that here I'm saying, okay, let this be my 14 Newton. That is for the load that is placed at the center. And this 20 Newton, remember we already put it at the center because the question says uniform, and we have explained the reason why we put it at the center. So how are we going to do the two? Well, you can consider both of them separately, but in this question, I'm going to join both of them together. I'm going to join them together. I'm going to consider them as one. So I'm going to treat them as one. So I can add them together because they are going in the same direction. So I can add them together like this. So the total weight at the center now is going to be equals to 34 what? 34 Newton. Do you understand that? It's going to be 34 Newton. So we can continue the question now, right? So find the force that should be applied vertically upward at Q. Okay, this is point Q. A force that should be applied vertically upward. So let's say vertically upward, that is straight upward like this. What is the force? Okay, we can do something like this. Then I don't know the force, so let me put F here. You understand? So let me put F because I don't know the force. What is the force that should be applied vertically upward at Q to maintain the rod in equilibrium horizontally? You know, we just follow the question to do everything. Now, if this is not, this is rough, you can actually draw another this thing and just identify the forces that are acting. So this question is very simple. We can quickly do it within few seconds, and because we are explaining, and that's why it's taking our time. Here now we know the forces that are acting on this rod here. So a force is acting downward here, right? That's one, and a force is acting upward here. Now I'm taking moment about we are going to take moment. Remember, this question is a moment of a force. So we are going to take moment about this pivot here. So we don't need a force at this pivot. I'm not going to explain beyond that. So now here now we have this force here acting downward, and we have this force here acting upward. So those are the two forces that we are considering, right? Now you have to know which one is clockwise and which one is anti-clockwise. So this is clockwise. This thing can move about this point. So this is acting downward, clockwise. This one is acting upward, anti-clockwise. So like this is anti-clockwise, rotating like this. So now we have to find the clockwise moment and anti-clockwise moment. So we say clockwise moment is equals to the force times distance. So that's going to be 34 times perpendicular distance. Remember, we are taking moment about P. Take moment about this point P from about this pivot. So this force times the distance, perpendicular distance. This force times the distance from this point. That is 0.5, right? So 0.5, that's going to be 34 times 0.5, that's 5 over 10. You can use your calculator to do this, and 5 here 1, 5 here 2. 2 here 1, 2 in 34 is going to be 17. So our clockwise moment is 17, right? So anti-clockwise moment now, anti-clockwise moment, that is going to be equals to the force, right? This force multiplied by the what? Multiplied by the perpendicular distance. From this point, we are taking anti-clockwise moment about the same point. So force times the distance from this point is 1. Remember, it's not 0.5 because from here to here is 1, right? So F times 1, that is going to give us what? F. And don't forget, this is our force here that's going upward. Now, what is according to the principle of moment, if a body is balanced, that is, if a body is in equilibrium, the sum of clockwise moments about a point is also equals to sum of anti-clockwise moments about that same point. So the clockwise moment, the anti-clockwise moment, it means that they have to be equal because the body is in equilibrium. So we are going to say the clockwise is 17 equals to anti-clockwise, which is what? F. Therefore, our F is going to be 17. So 17 what? 17 Newton.